Welcome everyone to AI Explained, this webinar series that we've been doing at Fiddler. I am the founder and CEO of Fiddler, Krishna Gade, and I'll be your host today. Here with me is Peter Norvig. Welcome, Peter, to the show. Peter Norvig is a legendary figure in AI. I'm sure that a lot of you have read his book on the AI, A Modern Approach. I've read it in my grad school. He's currently a distinguished fellow at the Stanford Institute for Human-Centered AI. He's worked for a number of years on Google search and improving search quality. So welcome to the show, Peter. Thank you. It's an honor to have you here.
Yeah, great to be here. Thanks.
Awesome. So Peter, we are in this midst of this revolutionary thing called generative AI, and you've been working on AI. What are your thoughts on generative AI?
It's amazing this era that we're in and sort of how fast things are moving. I guess, I started out in the days of the good old-fashioned AI, where things move very slow because we said the way we're going to put knowledge into a machine is to hand code it in some logical language using the blood, sweat, and tears of graduate students. And so you can never put that much in. And there was also kind of the maximum you could reach, because as you started to put more in, it started to contradict each other. And because we were basically using logic with a few non-monotonic exceptions, you couldn't really resolve those conflicts. So that was discouraging. And then we moved to machine learning and suddenly said, well, now we have kind of an unlimited amount of data to learn from. All we have to do is come up with the right representation. And we thought that that would be the hard part, saying what representations are we going to use for all this information? And then neural nets came along and said, they're going to make their own representations, and we're going to make them deep enough and have the right architecture so that the intermediate nodes can form representations. And it seems that they do a pretty good job of that. And we still don't quite understand why, but it's really exciting to see how fast it's moving.
Awesome. And as you sort of reflect in your book, right, artificial intelligence has changed over the years, and from logic programming to like machine learning now to generative AI. How are you seeing this, this whole emergence of foundation models? Where do you see the future of generative AI go? Do you see a world where people would just like use foundation models and build off of them? Or do you see the old school kind of model training still exist? How do you see the world in the next 10 years?
Yeah. So I think the old techniques will still coexist. As a textbook author, I'm thinking, do I now get to throw away 25 out of 28 chapters? And,
just focus on prompt engineering.
And I don't think that's right. And I think you can see that, right? So look at things like AlphaGo, the Go playing program. So the main innovation was saying, we're going to represent the state of the board with a neural net, and convolutional neural nets are good at representing pixels, and Go pieces on a board are kind of like pixels. So that's a good representation. And I think that's what made the difference between that and previous systems. But they didn't just say, let's just have a generic neural network. They said, let's use these techniques that we already know about, like game tree search and so on. And I think going forward, we'll have more of that. We'll say, what techniques are appropriate? Now let's figure out how to combine those techniques with a general representation, like a deep neural network.
Yeah. One of the things that you mentioned just now is that this deep neural network learns patterns from data, and we don't know how or why it works. And therein lies a lot of risks, and people talk about concerns around generative AI, right? There's a lot of talk about AI safety these days. What's your take on that? How does an organization or anyone think about this?
So I think safety is really important. I think there is some confusion, right? So we talk about neural nets are hard to explain because it's just matrix multiplication, and they're big matrices with lots of numbers. as opposed to other techniques maybe are easier to explain, like a decision tree or just straight line code. But I think there's a confusion there that part of the difficulty in understanding comes from the solution, being a neural net, but I think more of it comes from the problem. And problems are hard to understand, no matter what solution you use, right? So, if your problem is coding up the system, the software for a bank, then that's hard to get right because there's a million different regulations on what taxes and what fees correspond to what transaction. But that there is a right answer, right? And so if you looked at it carefully, regardless of how it was implemented, you could say, yes, this is right, or no, it's wrong in this case. But I think with AI problems, part of the difficulty is that there is no ground truth, right? So here's a picture, we do object recognition. Some of the objects there's an obvious correct answers, but other ones, is this a dog or a wolf? Well, nobody knows for sure. Yeah. So there is no ground truth. And that's where the difficulty comes in. And one of the things, the example I like to use is we say, well, neural nets are hard to explain, but decision trees are maybe easier. And yeah, maybe sometimes it's a good idea to say, let's build a neural net now, let's translate it into the closest decision tree and see how the two compare. And if they're close enough, maybe you want to use the decision tree at runtime. And we say, well, decision trees are easy to understand because it says if A and B and C, then X. But if that were true, then, regular software also has if statements that says if A and B and C, then X. And regular software has bugs in it. And why does it have bugs? It's because somebody looks at that and says, yeah, that statement's correct. And then at runtime, there's an error.
Right.
And then they say, oh, well, of course I meant if A and B and C, but not D, then we should do X, right? It goes without saying that it doesn't apply when D is true.
Right.
And that's where the bugs come in, right? And so that type of bug, that kind of weird exception that you didn't think about, that comes about because of the problem, not because of the solution, whether it's the
human understanding of the problem.
Yeah.
Subject matter expert. So there's like a human in the loop in software building, and so you're able to.
Yes, I think you want a human in the loop. You want automated tools in the loop. You want different types of representations and explanations. You want lots of tests. You want red teams to try to attack it. But there is no one solution that's going to say this is the answer.
It's a very interesting point, right? So essentially problems are harder, and you need human subject matter expertise to decipher them. And you build software, and then software can have bugs, and therefore you still kind of do this software practices. AI makes it completely different. AI itself is a black box. There is no ground truth, and so therefore you need to invest in all of these things. Now, one of the things that I'm actually very curious is that you were a big proponent of simpler models and large data, back in the day. I remember watching your lecture, when I was working at Bing and you were at Search Core at Google Search, and you had proposed that, hey, great data with simpler algorithm will always beat. How are you thinking now with the models becoming more and more complex and zero-shot learning, one-shot learning, emerging, how do you view this world today? The complexity of algorithms.
Yeah. So I think that's right. I've seen that progression, and we can see that going back to the editions of the textbook, right? So in 1995 was the first edition, and my co-author Stuart Russell, I think we kind of felt like, well, AI is part of computer science. Computer science is about algorithms. So this book is going to be mostly algorithms with some explanations of what's going on. Then we got into the second and third editions. You get up into the 2000s. We have this era of big data, and we said, well, we're still going to have all the algorithms. It's still going to be a thick book, sorry. But as we were saying, if you want to improve, there's probably more leverage in getting better data than in getting better algorithms. And I think that's proven true. In the latest edition from 2 years ago, I think we had a revelation that said, up to now, we've been saying you get your algorithm, you get your data, somebody hands you an objective function, and your job as an engineer is to maximize that. But that objective is a given. I think we're saying now, well, maybe that's the hardest part. So don't just say that's outside of the field that was handed to you by somebody else. Say, figuring out what your objective is, what you're trying to optimize, what's fair. That's the hardest part. And, you know, if you get that right, then the data and the algorithms, that's easier.
So we are now living in the age of complex algorithms, right? You know, the models have become more complex, and there are things that we are seeing, you know, hallucinations is a good, you know, example, you know, models potentially leaking private data, you know, bias is always an issue that people are concerned about. You know, let's if you think about hallucinations, which is essentially something a lot of, you know, a lot of our customers implementing generative AI. What's your take? First of all, why do these generative AI models hallucinate?
So I think, you know, a synonym for hallucination is creativity. Right. And so, you know, if you ask the system, design an outfit that I can wear to a party, and it comes up with an outfit that's never been seen before, you say, awesome job. You know, I love it. That was very creative. Kudos to you. But if you say, I'm filing a court case before a judge, and it comes up with precedents that had never been seen before, that's illegal. Right. And so the problem is we haven't told these systems when they should be creative and come up with something new, and when they should be reporting. And, you know, there's various approaches to do that. I think we can do, there's been experiments with saying, well, you should have access to knowledge bases. So maybe you should be looking some of these things up. You know, if you think about, well, how do we humans operate? You know, if you ask me the capital of France, I can say Paris. But if you ask me, you know, the capital of every county in every country in the world, most of them I'm going to have to look up. Right. And so our systems should be doing that, or they should be calling out to other expert systems and putting pieces together. So I think it's, you know, as you say, the architectures get more complicated. And one of the things we have to do is separate out the creativity from the factual reporting and sort of the documentation of where the arguments come from.
So the attribution is a hard problem, right? You know, if you can make the models attribute to where they're getting the content from. Do you think like we will arrive at technology that would allow us to do that in the future, like where models can actually self-attribute, like in the references from document data?
Yeah, I think so. I don't see any barrier to that. It's just, you know, we thought the easiest thing to do was just say, let's feed in as much text as we can. But I think we've already seen that with if you annotate the text, then you can come up with better representations. Right. So I saw there was a nice paper, I've forgotten the name of the author now, where they trying to train a model to be a dungeon master to play Dungeons and Dragons. And you could just train it on the transcripts, but then it doesn't do very well. But you can annotate the transcripts to have kind of the state of the game and, you know, what the players are and how many hit points they have and so on. And when you put in those annotations, then it does much better. Right. So I think that's the kind of thing we should be doing, is saying, you know, this is a citation. There are things like journals and articles and facts and databases and so on. And don't just dump everything out of there as text, annotate it to say where it came from.
So one of the things with hallucinations is, especially, it's okay, as you said, you know, for a, you know, ChatGPT or something to be creative and hallucinate. So we work with enterprise customers, and we were helping one of the health insurance companies to create a chatbot recently. And so it was, so there was this simple question called, you know, what is a, you know, well-known soft drink that would help, you know, human health condition positively or something. And so the right answer is there is no such scientifically proven soft drink. But you can make the question slightly different, and then you can have text Da Vinci hallucinate and say answers like water, red wine, and stuff. So this is potentially, you know, if for example, if a bank wants to use it for wealth management, or healthcare company wants to use this for clinical diagnosis in front of like a physician or something, hallucinations can be problematic, right? Like, how does one think about preventing these things, like using whatever existing techniques and tools one may have to do.
I mean, I guess the first thing to think about is this is not a new problem that comes from generative AI, right? So we're exposed every day to advertisements, and some of them are outright lying, and most of them kind of just go right up to the barrier where they make implied claims about health or whatever, but don't quite make a medical claim. And they're designed to trick us into believing those claims. So it's not surprising that our AI models pick up on that because it's everywhere. And to combat that, you need more critical thinking, right? So you need that as a consumer of the news and advertising, and you need that as a check on these models.
So you bring up this point that AI models are not perfect; they're error prone, and therefore you need some sort of a monitoring of these AI models, and some human in the loop. The other sort of concern is like the bias thing, right? So we have now these foundation models scouring the web and processing the content. And then they can be learning all the biases that people have written on the web, right? And now, like, that's a big concern. How do we create a world where generative AI does not advance discrimination? Like, that's a big problem.
Yeah. So I think a couple things. So one is you want to be measuring how you're doing, and one is you want to have awareness, and I think part of that is just having diversity on your team in terms of what groups are represented, what nationalities, what cultures, and so on. And because if you don't have that, you won't be able to recognize some of the bias, right? And we've seen that in things like the major search engines. A few years ago, you do an image search for bride, and they're all white dresses. And now you do that, and it's more diverse. And then you say, well, gee, there are different cultures, and they have different traditions, and they have different kinds of traditional dresses. And that came about because someone noticed that it was an issue and said, we need to have some diversity here, and then went about doing it. So you're always going to need diverse teams that are aware of the issues and can combat that. To some extent, some of that falls out in that there's always this idea that diversity is good. And the first reason it's good is because, going back to search, if you put up 10 links, it would be bad if all 10 links were to mirrors of Wikipedia to the exact same article. Right? So instead you say, well, we'll put the best one first, and then the second one should be the link that adds the most information, assuming that you've already seen the first one, right? And so that kind of automatically gives you more diversity because there's only value of information to something that's new. Then there's another kind of bias besides just, so there's bias in the data sources because societies are biased, but there's also bias for the majority, because machine learning models work better if they have more examples. So even if some minority group, there's no prejudice against them, everybody likes them just as much as the majority group, they have less data, they're going to do worse. And then there's bias in terms of, as an enterprise, you have to decide who your customers are, and at some point you're going to leave some of them out. And again, this is not new to AI, right? So for decades, we've had companies that say, we're shipping a product, we're going to put an instruction manual in that product. Majority of our customers speak English, so it'll be in English. And then one day they say, we have a pretty good minority that speaks Spanish, so let's put in a Spanish manual as well. And that's an additional cost in translation and paper and so on. And then you have to say, am I going to add a third and fourth and fifth language? And at some point, there's a cutoff, and some people get left out. Okay. And that's always been the case, that if you're in a minority group, you're going to get less attention.
That's a big problem, right? Because someone is asking, I think Charles Vicha. So it seems like the internet is authored by a majority group, right? Like the privileged group. And so there's, most of the sources, data sources, as you just articulating, came probably from the people that had access to the internet first, and they could write content. And now generative AI gobbling up this information could actually undermine those like other emerging countries and people who don't have the same kind of access to the internet and probably have not had the chance of putting their content out as much, right? How do we? And then now there is a problem that we might be living in an age where generative AI models are feeding each other off.
Yeah.
Because if the content generation is going to be automated, now a model could be generating content, which will be then feeding off information to the other model that is coming in the future. So now you'll have a propagation of this sort of bias like at a much larger scale.
I guess I'm not too worried about that. I mean, I could see a future where that's a problem, but a couple things. So one is we worried about this a decade ago with machine translation, right? So we were offering machine translation service. People were using it, posting stuff on the web. We said, well, what if we're getting feedback from our own output? So we did an experiment where we watermarked our output so we could probabilistically tell which was ours. And it turned out it was a very small percentage. So it wasn't a really big deal. So one answer is, if it's going to be a small percentage, then you shouldn't worry about it.
Yeah.
The other answer is, if you can detect the difference between quality and non-quality, then why should you care whether it was generated or not?
Right, makes sense. So it seems like one of the things that we need to pay attention as AI sort of progresses is to have some practices and to implement it safely, to have humans in the loop. But maybe drawing from your experience of building probably one of the world's first large-scale ML application, which is Google search in some ways, what advice would you give for companies to build large-scale ML applications, from whether that's predictive ML or generative AI? How does one go about the process of building a great and responsible and safe AI application?
Yeah, I guess the first thing, and I spent a lot of time advising startup companies on their machine learning practices. And so many times we have this conversation, we're coming in, they say, oh, there's this deep learning stuff and it's so complicated and there's all these maths and there's partial differentials and so on. And I'm nervous about that. And I would say, get started. A couple of months from now, you're going to be completely over that nervousness. And, this big black box in the middle that you think is so big and scary, that's going to look small and tame. And instead, what's going to matter is this pipeline of the data coming in and then how you serve your customers. And all your attention will go on that, right? So finding the right data, generating new data if you have to, having human oversight of that, having automated ways of cleaning it up, and then how do you serve it, so on. That whole pipeline becomes the important part. So I think that's the first lesson that people come to.
Sure. And where does AI observability fit in this picture? I'm sure like when you were building these ranking models at search, you were having some sort of a feedback loop, right?
Yeah. So we thought of it as 3 levels. Yeah. So one is the clicks, right? And both short term, did people click on the number 1? That's probably a good thing. Yeah. Unless they come back right a second later and then click on something else, then maybe it was misleading. Right. And a little bit longer term, are we keeping our customers or are we losing them? Yeah. So that's at one level.
So like business level data.
Yeah. Then at the next level, we said, well, we can't do it by clicks alone. We really need some human judgment. Yeah. So, we had paid workers to say, is this a good result or not? Yeah. Was the user happy with this? Of these 2 possible versions of the system, which one produces better results? Yeah. So kind of, we didn't call it reinforcement learning with human feedback, but that's the kind of thing it was. And then the third level was we would bring people into the lab or we would go into their home
Yeah.
and we would observe one person at a time super carefully.
Yeah.
We had the lab with the mirrors and the cameras behind the mirrors and so on, and said, well, do a search.
Right.
How would you do this? Think aloud as you're doing it. Say what's confusing. How is it working for you? And so from having that, billions of clicks, thousands of human judgments, and a single person at a time interview, those three levels put together gave you a better picture of what was going on.
Got it. So like business level data, human labels, like getting the ground truth. In some cases, ground truth is hard to achieve. Like, for example, we work with large insurance companies, banking customers, you wouldn't know until someone pays their first installment and whether they've issued a good loan or not and things like that. So what's your take on data drift and, people are starting to monitor these signal drifts, right? How do you think it will help, ML team?
Yeah, that's hard, right? And I think you're right that, maybe with business it's a little bit easier. Are people actually paying or not, right? You can see that. There's other places where it's even harder, right? Yeah. So there's been a lot of controversy over AI systems helping in the justice system, right? Making recommendations for, should you get parole because are you going to recommit a crime? And part of the problem there is we don't have the ground truth, right? What we really want to know is, are you going to commit a crime? Yeah. From that, we look at similar people and say, have they committed a crime? We don't have any records on who commits a crime. All we have is who's been arrested and who's been convicted. Yeah. And both of those processes can be biased, that the selective policing in certain areas or selective choice to arrest or not, and then bias in the juries of who they convict or not. So we don't have any ground truth. Right. And in order to deal with that, you have to estimate, well, how much bias is there in the data that we have? Right. And that's hard to do.
Right. And then what would one need to do, like in the case of where the ground truth is not available? Is there another way to kind of like get some proxy measure in terms of how well your model is performing at any given point of time? Have you seen anything work in practice?
Yeah, so you can look in depth. You can sample a few cases and look in more depth, right? And we see that in the justice system. There's like these innocence projects of saying, here's somebody that was convicted in the past. Let's look more closely. Right. We have better tools available today, like DNA analysis. Right. Were they wrongly convicted? Right.
So having some sort of a human in the loop in the work.
Yeah. And if and you only have to sample a small number of cases and look at them in depth to have a better idea of are you making systematic mistakes.
Switching gears a little bit into sort of a sister topic, right? So, AI from a technology point of view is fascinating. It can enable so many things. But then what you think is a social responsibility for companies implementing AI? How do we create, I think this is a question coming from Deborah Adams, how do we create an ethical standard that is being woven into the most of the tools that we use today? How do we want to make sure that the AI will be used for good, without intense slowdown?
Yeah, that's hard. And as I was saying, right? Yeah. So in the latest edition of the book, we said that's the hard part, is saying what's fair, what do you want to optimize, what is your true utilities? Yeah. And I think we've seen a lot of effort in that way. So all the big tech companies, many of the governments, many other organizations have their AI principles. Yeah. I think that's good as far as it goes. I wish there was another level to that, right? Because, you have AI principles that say things like you should respect the user and their data. Right. And that sounds good. But say I've got a database of faces, what am I allowed to do with that? And what am I not allowed to do, right? That principle alone doesn't really tell me what the limits are, right? So I would want another set of principles that says, in terms of surveillance and facial recognition, here's the allowable things and here's things that you shouldn't be doing. So I would like more detail on that. It'd be great if we could get consensus on that.
Right.
We'll never get complete consensus. You know, the things that we think are right in the US will be different than what they think is right in China. And that'll be, I think you're reconcilable. You know, maybe we can reconcile the US with the EU, but we're not going to get there completely. So I think, you know, you have to say, what is it that you're trying to achieve? How do you agree on these things? And then how do we implement a system that checks that? How do we put in training so that engineers will build the systems that respect it? One of the things that was important to me was kind of broadening the viewpoint, right? So I recognize that as a software builder, I was mostly thinking in terms of the user. And that's not enough, right? So as the question says, you got to think about society as well. And I think of it in terms of 3 levels. So if we go back to this criminal justice system, you know, so there's one user, and that's the judge. And if you're building a system to assist them, you know, you want to have a great interface, and there should be fancy charts and tables and all the information in the right place so that the judge can make a good decision. But you're not done that, because the judge is just part of the whole system.
The implications on others,
Yeah, and so the next level is who are the stakeholders, and that's the defendant and their family, and the victims of any crimes that the defendant committed or may commit in the future, and their families. Those are all important stakeholders, and you want to think what's fair to them. And then there's society as a whole. You want to think of, well, what are the effects of mass incarceration and bias of various kinds on the system? And so just optimizing the screen for the user, that's not enough. There's a lot more left to do.
That's a great point, right? I think it just spans beyond criminal justice. You know, you're not building AI for the underwriter in the bank, but also the person who's applying for the loan and the society at large. It just extends to so many things. You know, you're not building AI for a physician, but like the patient and everything. So amazing. So again, that's where it comes down to this whole aspect of how do we create an incentive for organizations to do this, right? To build safe AI. You know, do you think regulations have a place here? Like, you know, the EU AI Act as well.
So, I mean, part of it is saying, well, you should do this because it's the right thing. Part of it is saying you should do this because otherwise your business is going to get in trouble of various kinds. And so I think there should be a multifaceted approach. I think there should be regulation, but regulation does not move at the speed at which technology moves. So it'll always lag behind, and regulators are not technology experts, so they may get some things wrong. So that can't be the only approach. I think internal self-regulation is important. You're seeing the tech companies do that, in part because they think it's the right thing, in part because they want to stave off regulation that would make mistakes. I think there's a role for technical societies, right? So the ACM and IEEE and so on, they have codes of conduct. They could do more of that in terms of education and so on. I don't know if certification would be part of that process, right? So right now, you know, anybody can call themselves a software engineer and go out and build a piece of software. You don't need any degrees or certificates or plaques on the wall or anything. That's not true in other fields. I can't say, I'm a civil engineer, I'm going to go build a bridge. Right. I need proof that I'm allowed to do that. So I don't know if we need that for software, but maybe we want that as an optional approach. And then another part of the puzzle could be third-party certification. So I recently joined an AI safety group that's being put together by Underwriters Laboratory. And I think they're interesting because 100 and something years ago, when we had a last technology that was going to kill everybody, it was electricity. You know, and there were these big public scares. What's electricity going to do? And you could see these old cartoons of people getting electrocuted and so on. And Underwriters Laboratory came along and said, okay, we're a third party. We don't have anything to do with the government, but we're going to do an inspection. And we'll put a little stamp on your toaster. And if it says UL on it, the customer can be assured that it's probably not going to kill them.
So this was a private lab.
Yeah, completely private.
Interesting.
Completely optional to get certified from it. But the companies saw that the consumer trusted the brand mark, and so the company said it's worth it to us to get certified through this. And so that could be another possible route. And maybe these third-party independent companies can move faster than regulation can.
Interesting. That's a great point. I guess we probably take another question. Aren't the business owners and shareholders also stakeholders? How do we reconcile doing the right thing for the society and influencing investors and C-suite? Yeah, this is very interesting, right? So recently I was at a conference where there were customers who were telling us that AI is now like a board level thing, unlike the last few things like the big data or cloud computing. It seems like the boards are very much influencing the C-suite in many large companies about AI strategy, and there's almost like this gold rush thing, right? Like, what are we doing? You were articulating everyone wants to create a chatbot, So how do they need to think about it? I'm sure a lot of people are not aware of all these things, right, that we just talked about. What do you think we should do here? What do you think like organizations should do?
I think successful organizations worry about the bottom line, but don't obsess over it, right? And they think we're optimizing for the long run. We want to be here. So this quarter's profit is not the thing that I have to maximize. Rather, I have to build a sustainable company. I remember Tim O'Reilly of O'Reilly Publishers saying, revenue, I guess he said this a number of years ago. So he said, revenue is the gas that makes the car run. Now maybe it's electricity that makes the car run. But he says a road trip shouldn't just be a tour of gas stations, right? You're there for a purpose. And so I think companies should think first, what's our purpose? We're going to make society better while making a profit.
Right.
But the goal isn't only to make a profit.
Right. Yeah, makes sense. I think basically ethical AI will sort of safe AI will result in actually building better AI products, and eventually it will help the companies along. So I guess like, rounding off, right? So there's basically coming back to like where we started, the foundation models are now the rage, and we now they're open source availability of these foundation models. There is dangers of like, people abusing them, potentially building, ransomware programs, deadly viruses and whatnot. So, what's your take here? And how do teams think about it? How do we, I guess like it probably just summarize all our conversation, but like, what's your sort of overall take in terms of technology, ethics, safety, all of these things combined?
So a couple of things. So one is safety is really crucial, and it should be an important part of everything you do. Secondly, I don't quite understand why there's so much emphasis on some of these results, right? Of saying, look, I can jailbreak a chatbot to tell me how to build a bomb. But it was a lot easier just to type a search, how do I build a bomb? And that information was already out there, and the chatbot resurfaced it. So it doesn't seem to me like that's a new threat, right? So the new threat would be if it's synthesizing information that's hard to find in order to do something disruptive. And most of the examples I've seen before are not like that. They're just resurfacing something that's already out there. So I don't see that as a huge threat. But we do want to defend against that, and we do want to make things safe, and we have safety at a lot of different levels, right? So we put cheesy little locks on doors that any professional thief could get through in a second, but it keeps the casual person out, right? And so I think a lot of this AI safety here is for keeping that casual person out, the person who really wants to make the ransomware. We're not going to be able to stop them anyways. So how do you do that? I think red teaming is really important to say, let's think about how people are trying to jailbreak these systems. So the base level is reinforcement learning with human feedback and the fine tuning to sort of build systems that are resistant to that. And then as new attacks come up, you should go in and make your system safer against them.
Can you double click on the red teaming? I don't think a lot of people know what a red team is and what does it do?
So it means, the engineer should say, okay, we're going to try to build a safe system we can. But when they say, okay, it's passed all the tests we thought of, that's not enough. Rather, you should have a separate team that says, my job is to try to break the system.
Right. Like QA the model, basically.
QA the model in every way I can. And you want to bring in people that are experts in that. So the people that are making ransomware and so on, and know all the tricks, and let them try as hard as they can to break into the system. And then you go back and forth and try to fix that.
Makes sense.
And then I guess the other thing is I'm kind of two minds about this open source, right? So we saw in the beginning, companies, and maybe it was a PR ploy saying, oh, well, we're not going to release our models because they're too dangerous. And one way to make customers want things even more is to say you can't have it. So there may have been some PR involved there. But I think it was a good idea to say, you're only going to get access to these models through an API. And that means we can monitor what's being done. If we see something being done wrong, we can either fix that particular attack or shut the whole thing down. If you open source a model, you lose the ability to do that. Now, the bad guys can do anything you want, and you have no way to monitor what they're doing. So I'm a little bit worried about the ability to take these models and work on them unconstrained.
Awesome. This is great. Well, thank you for sharing your words of wisdom, Peter. Here, it seems like organizations need to invest in AI safety and responsible AI and sort of how do we make this not just for the user but also the society as a whole, right? So I guess there's probably one last question that we'll wrap up with. I guess what's to prevent a developer from creating responsible AI that would be unsafe, biased, unhygienic, inaccurate, that could cause humans harm? In other words, how do we humans control AI? I guess it's probably just a summary of the entire conversation. But any closing thoughts?
I guess I would broaden that to say, how do we control against malicious uses of technology in general? Right. So a lot of the technologies we have dual purposes, and all are kind of energy technologies, right? So as a species, we invent fire, and that's good for a lot of things, but it can also be destructive. Exactly. And we invent vehicles that go fast, but then you can crash them into things. So any technology can be put to bad use. We talked about ways to make it harder to do that, to put them behind APIs so that you can lock them up, to put preventions against the casual user. But I think with any kind of technology, it's hard to have preventions against the professional dedicated user, right? So if something has a capability, they're going to be able to use it. And I'm not sure the extent to which AI makes that particularly worse, right? So I think you're already able to do a lot of the things you could do without the AI technology. Right. Maybe makes it a little bit easier.
Right. Makes sense. Awesome. Well, on that note, thank you so much for joining this webinar. We'd like to thank Peter. So there's probably 3 takeaways that I got from this. One is essentially every organization needs to self-regulate, and have to put processes and tools in place so that they could deploy safe, responsible AI. And it seems like there's potentially a need for third-party ratification in the future so that AI engineers don't go and build their own things. And then obviously we all, as a society, we're responsible. Teams are not building AI for a particular user, but the entire society, and it has these deeper implications. So, but with that, thank you so much, Peter, for coming on our webinar. It was a pleasure. And thank you for everything that you do for
Yeah,
us.
great to be here. Thanks.
Thanks.